Okay, what we have here is my dynamic grunge and material, fake interior material for fake windows. Now, this is the daylight scene. I will switch to the night soon so we could see the interiors, but for now, I will say that this thing is mostly driven by custom primitive data, but you can switch that off and create your own independent material instances. I do this because it's better for draw calls, and you don't have to create many materials. It just could be all on the same material. Now, every single window uses the same mesh as well. So again, they are batchable and instanceable. First, I'm going to start with the grunge, the dynamic grunge. As you can see, with custom primitive data, you can switch out various levels of grunge, and you can make them different from every other window. For instance, on this window, let's say we want to, let me find the values. Mid grunge amount is here. There's a README file within this that allows you to know all the values. But this is the mid-range grunge. I could disable or, lessen or make greater. I have, let's see, 28, 29. So I have the amount of tiling that the grunge could do in either direction. And you could obviously put in your own grunge texture if you really want to create your own material instance, but this one works. And then you don't want every window to have the same grunge, so you could also, let's say you like the values but you want a little variation, you could always move the grunge left and right. And that's probably more apparent here. You could have different edges because you're moving it. So moving it up and down, so you can see where the edges differ now. And then we have grunge step max A and B. Let's see here. So this is going to be 32, the very edge where it's really accumulated heavily. And then you have one for that little mid-range. I don't know if you could notice, might notice it more over here. That mid-range of grunge before you get to the very center, which is barely there. But you could control how far that mid-range goes too. All these windows do have the typical Fresnel effect that any glass would have, which basically just comes with the PBR. And they will use screen space reflection. That's if you have it enabled, I guess. But in either case, let's see what we want to do now. Okay, so as I said, this is using real-world lighting units. So this directional light, I put it like 100,000 lux or something like that. Disabling that, and I included a post-processing volume in this scene for you guys to look at that I found was acceptable top and low values of light, so that the windows look good in both day and night. And so now, for whatever reason with Unreal, when I'm using convoluted bloom and everything, I don't know if it's convoluted bloom or all blooms, but it looks weird and overly bright when I'm not in full screen mode. It looks fine when I put it in full screen mode, so I don't know what that's about. If anybody has any answers for that, by all means, hit me up on Discord or an email. But, so this with a dynamic grunge, you can see the grunge does block the emissives as well. So now, this next thing I'm showing is the interior mapping. I included a bunch of different interiors, and really quick, I've only included material instances that uses the HDR cube maps because they look a lot better. But you can get away. I have also included non-HDR cube maps so that it's not as basically the lighting is more uniform, but you can still adjust it. It's just a way less memory, but I find that the memory cost is worth it, and just because you could see the highlights coming off actual light bulbs when you're using HDR, and it just makes it look a lot more believable, especially from a distance. But this these material instances are also using a texture array for all the interiors, so I could switch out the array with custom primitive data values. So you could switch the actual interior based on custom primitive data. So we want that room, that room, that room. You can do it all. Is my point. So, and I'll get into the fact, well, I'll get into it now. These rooms also can be rotated with custom primitive data. As you can see, each floor should be, I thought I set them up as the same room, but let me see, how did I set this up now? I'm actually confusing myself. Oh, okay. Yeah, okay, so the top to bottom should be same room, and then it rotates when we move left and right. Right? No, rotates top to bottom, and it's left to right is different rooms. That's what I'm doing, okay. But you could see, second one is a different room, and it's all got different rotations, same for this one. And that's just another way of adding variation to these rooms, without having to add an entirely different cube map. It's just another way of saving on memory. And this is another example of the same room being rotated. Now, you can actually rotate these rooms so that, let's see, cube map rotation. That's number 3, custom primitive data. You don't actually have to rotate it by 90 degrees. You could do something weird like that. Artistic freedom. I wouldn't recommend it, but it's there. I would rotate it by 0.25. 0 to 1 values. Now we have room scaling and positioning. Now we have a lot of custom primitive data that allow you to adjust a room. Again, this is just another way of adding diversity to it. But for one, we have the cube map depth. I'm just gonna bring back Super Bloom instead of being full screen for this. But let me see here. Cube map depth. It's like your position of the camera from that you're viewing it. You could see it's a good way of simulating maybe you're got a hallway along the window or something. You have X adjust, so you can move the room left and right. Y, you can move the room up and down. In fact, you could also scale the geometry and the room will stay the exact same size because the material does take into account the scale. You'll just have to reposition it, but it does keep everything else. The room is not going to be stretched and skewed based on the size of your window. So that's good. But we can also, let me find it, 10, 11, okay. Scale the room, we have scaling controls. Up and down, front and back, make the room like a giant room. Where am I? Oh. 9? There we go. Left and right. You can scale it. You can even scale in negative values. So you can flip the room. It's another way of adding variation. Now we have, again, we have emissives. You could turn the room lights off or you could change the color. It's 3 custom primitive data values for red, green, and blue. And you can make them way past 1 and you could blow it out to make it like a super bright room. You could dim it some more, change the color, you get the idea. And with Lumen, obviously, these are all casting their own lights, so that always looks pretty nice. You don't actually have to, when you're lighting a city, you don't need to add lights on every window. Now, this here is curtains and blinds. There's their own separate layer, and they also can be a separate texture or an array. The texture could be an atlas, like a virtual texture, where you could actually just move the curtains left and right, up and down, or front and back. But let's see. So this one is front and back controls. As you can see, the curtains now appear in the center of the room, but I'd rather have them here. 0.02 is usually a pretty good value for these. 0.01, 0.02. But 24, 25, that's to move it left and right, and up and down. Then we got multiplication values where you could make them wider or taller, shorter, whatever, just scaling it up and down. And obviously you can move the UVs into position after that with those other values. What am I missing? So we got curtain front to back. We could also change the color of the curtain, obviously, and the transparency, so that you could match the color of the room, or you could make it look like it blocks more light, or you can make it like just a transparent, nice decorative curtain that is just there. Obviously, these are the many variations I have. I'm using this material instances uses a texture array, so it's easy to switch them out. Just like I switch out the interior room, it's a custom primitive data to switch out the type of curtain. So you just flick the number, you get a new curtain. Now this one simulates blur. It's the same material, obviously, but it's got a custom primitive data to simulate blur, like frosted glass, like a shower door. Bathroom window, that sort of thing. And that would be, let me find it. Interior MIP bias, number 17. And you can see as I drag the slider, I could adjust it any way I want. Make the room look ridiculously blurry, little blurry, no blur, etc., etc. Now, I usually like to use this together with this feature right here. This is the normal map, but it also has a fake refraction element to it to bend the UVs to modify them so that they look like they're refracting. And technically speaking, when you are refracting, you don't need the highest resolution texture in there, so it's a great way of saving memory, I suppose. But right now, these are using the full memory or full resolution, but I could blur it. 1, 2, 3, 4. As you can see, this is using level 4 of MIP. And yeah, obviously the normal has options for scaling like everything else. The MIPs have custom primitive data values. The normals, positions, and scales, left and right, have custom primitive data values. So you can scale things up, make them tiny. These two are using the same normal maps, bigger. Same over here. Again, and then there's a custom primitive data to even adjust the refraction amount in here. Let me see if I can find that. I got a list on another monitor that I'm looking at, but I think it just goes along with the base normal strength, actually. So the refraction, the refraction automatically goes along with the normal. So as you can see, I'm adjusting the normal strength. That's also adjusting the refraction. And obviously, if I put daylight on, we have normal maps. So it's reflecting the environment based on the normals. Really quick, I'm going to show here that I included 5 material instances. I did so for a reason. For instance, this one is just a regular cube map with the dirty glass. It's got no curtains, no normal effects, no blurring effects. They all run very well in performance. So honestly, I would rather just use, for me, I use the one that has everything on it. Cube map, curtains, normals. But if you're really trying to get performance, I've disabled some of the static switch parameters for some of these and made them less heavy. This one is interior cube map with curtains. So this one doesn't have any of the blur or refraction stuff, but it's got the cube map with the curtains on it. And this one has everything, curtains, cube maps, all that stuff. This one is cube maps and normals with no curtains. And this one is a very special case. This one is no glass. And there's a reason I did this. If you point like a directional light at this thing, it looks weird. The shadow will be on the geometry. It's not going to go inside the room. So to remove that as an obstacle, I basically, and this is a very dim lit room, you can see the post-processing try to light it if I get too close or, But point is, there is no glass. You can see from an angle there's no highlight. That's because you're simulating an interior. This is for open windows. And what I do in the details for this mesh is I like to put it on a separate lighting channel. That way the directional light from the outside doesn't even affect the room. So it just looks like it's lit on its own. Separate world you're looking into. Now, in the back, I've got a lot of examples of various buildings. So that I've used in other environments. I didn't bring the entire buildings, just the windows for everybody to see. But here's some examples. You got the blurring, you got the refraction, you got a lot of different curtains and colors. You got that nice HDR blown out effect coming from light bulbs, depending on how bright or dim things are. A lot of different shapes of rooms and variety. When you're doing rooms like these, you know, you gotta line up the windows, so the room in the windows, so you gotta go front and back, left and right, until they line up, which is at first annoying when you got a window that's like this and two separate levels. But once you get it, you can just duplicate it over, and then you can just change the interior with some custom primitive data number values easily. But yeah, so again, rooms can be different shapes, different sizes, different colors, intensities, different curtains, all that stuff. Now, there was an interesting effect that I added that I have controls for in the material instance, but you don't really need to tweak them. I noticed that for things like blinds, there was a shimmer effect as I backed away, almost like an aliasing thing, but it wasn't aliasing. And the way I had to fix it is I had to go to a blurrier MIP sooner. But the problem was, as I went away from the building, the curtains would disappear completely. So I have to make the MIPS travel on two different levels. Once you get to a midpoint, it switches so they start switching slower. But in that beginning point, they blur out faster. You can't notice it with the naked eye here, but you can. But that shimmer was there, believe me, and it was annoying. So I hope you guys appreciate me fixing that for you. But yeah, these are lots of examples I've included for you guys so that you could have some fun. There are a couple windows under the floor. I didn't bother moving them. But you know, here, simulated a hallway. In a small break room or something. And it's like a high rise. So yeah, if you guys have any questions, you could always reach us on Discord or email me directly. And I hope you enjoy. Thanks.